Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien, and welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
Today, flights into space are usually reserved for trained astronauts, but a new technology being developed by NASA may someday allow anyone the opportunity to travel into space.
NASA's HyperX program is working on experimental engine designs that could eventually propel commercial planes into space. This new technology may make conventional rockets a thing of the past. Tonya St. Romain finds out more about this fascinating new program.
Have you ever dreamed of going to your local airport and getting on a cross-country flight that would take you minutes instead of hours, or getting on a flight that would actually take you into space? This may seem like an unrealistic idea now, but in the near future, these dreams may actually become reality. NASA researchers in the HyperX program office are working on a new vehicle. It's called the X-43. The vehicle will demonstrate technology that could someday allow aircraft to travel at incredible speeds, even fly into space. The X-43 has a revolutionary new type of air-breathing engine called a scramjet that may enable future spacecraft to take off and land like an airplane instead of blasting off like a conventional rocket. The scramjet engine may also be used by commercial airlines, and that would significantly reduce the amount of travel time between destinations. I spoke with NASA manager Vince Roush to find out more about the X-43 and the scramjet engine.
Tonya, the X-43 is a revolutionary new kind of airplane. What we want to do with this is prove that hypersonic flight with an air-breathing engine is possible. Hypersonic flight means flying more than 5 times the speed of sound. Today, most airplanes fly below the speed of sound or subsonically. This airplane, the X-43, which you see here full scale, inverted in the wind tunnel, uses a new kind of engine to do that called a scramjet or supersonic combustion ramjet.
Vince, what makes the scramjet so special compared to a typical engine?
Well, the scramjet is very much like a jet engine as far as how it operates. However, if you look at a typical jet engine on today's airliners, what you see are fan blades in the front that compress the air before it goes into the combustor section where it's mixed with fuel and burned to produce thrust. The scramjet engine, such as this one, uses the forward velocity of the vehicle as it moves forward in the air to ram the air into the engine so it can do away with those fan blades. It then mixes the fuel, burns it, and produces the thrust. That's much more efficient at the higher velocities that this engine operates at than using compressor blades.
What's the technology that's going to make this plane fly into space?
The technology primarily is that this engine, because it doesn't have moving parts, is designed to operate over a wide speed range, can actually fly theoretically up to 25 times the speed of sound, which is orbital velocity. What we want to do with this vehicle is show that one of these engines actually works in flight, something that's never been done before. So we're really excited about taking this to flight, show that it works, and then from there go to bigger vehicles to show that we can actually make space access vehicles that fly like airplanes.
The scramjet engine is very different from conventional rocket engines. In order to break free from the Earth's gravitational field, vehicles like the space shuttle use a fuel mixture of hydrogen and oxygen to propel the vehicle forward. Unfortunately, the oxygen and hydrogen must be carried in the vehicle, which significantly increases the weight, making it very expensive and inefficient to fly to space. Since the scramjet engine actually scoops oxygen into the engine from the atmosphere, it doesn't need the extra tanks to carry the heavy oxygen propellant. The scooped air, which is traveling above the speed of sound relative to the vehicle, is heated up as it reaches the combustion section of the engine. It's then mixed with hydrogen and burned quickly to provide thrust. This process allows the vehicle to move faster and faster, reaching orbital velocity, enabling the vehicle to break the gravitational field and fly into space.
We have a long history here at NASA Langley of doing scramjet research. In fact, over the last 40 years, we've built and tested over 20 engines. We've run 5,000 tests. If you ran these tests end to end, we would actually have enough test time to fly 5 times around the globe. Unfortunately, there's some things that we can't duplicate on the ground in a facility such as this that we have to take to flight. So now what we're ready to do is take engines such as this scramjet engine to flight.
All right, let me get this straight. The X-43 uses an air-breathing engine. What makes it different from other vehicles that fly into space, like the space shuttle?
The space shuttle uses rocket engines, obviously, instead of an air-breathing engine. What we want to do is take the cost of the space shuttle, which is about $10,000 a pound today, and by using an air-breathing vehicle such as the follow-on to the X-43, drop that price down to a couple of $100s a pound. That would mean that you and I could take a space trip. something that I'd very much like to do in the future. It would also, by operating like an airplane, take off and land on a runway. It would be much more flexible, much more reliable, and obviously much safer. So we want to really take airplane technology and apply it to space launch technology. And the scramjet is kind of a mix of both. And we're very excited about the potential for the future, and what we're about in this program is starting to prove that that potential is really there.
Vince, I know the X-43 is still in the initial test phase, but when might you and I expect that we could actually hop on one of these planes and fly into space?
Tonya, we have a lot of work to do before we get to that point. The X-43 is the first step. Beyond the X-43, we hope to have an X-43C, which would be slightly larger, and then going from there into fully reusable systems where we test them many, many times. I would say that realistically, we're talking about being able to make a decision on building a real airplane using the scramjet technology in the 2025 timeframe.
Currently, the world's fastest air-breathing aircraft, the SR-71, cruises slightly above Mach 3. The HyperX research vehicle will have the ability to fly at Mach 10, or 10 times the speed of sound, which is roughly 2 miles per second. Up next, testing shuttle tires at 250 miles an hour on the ground. But first, did you know that the X-15 was the first winged aircraft to investigate piloted hypersonic flight? From June 1959 to October 1968, the X-15 set the world speed record at Mach 6.7, or 4,520 miles per hour. It also set the altitude record of 354,200 feet and earned astronaut wings for 5 of its pilots.